Welcome to this topic on the engine exhaust system for the Airbus A320 family. The objectives of this lesson is going to be actually learning about what the engine exhaust system is there for. So function. Number two, what are the components related to the engine exhaust system? Three, the locations of some of the components, and kind of also just understanding a little bit about maintenance, so we'll have a little bit of maintenance tips in between. All right. Number one, the function of the engine exhaust system. Why does it exist? Okay, well, the reason why is we have engines. Engines are going through a chemical process using air intake, or the intake of air, right? And that goes through the combustion chamber mixed with the fuel. And then we have expenditure of hot gases. So that's one function of the engine exhaust system. We have two functions. Number one, the exiting of hot exhaust gases, and number two, it's for thrust, but not just forward thrust, which is why you have the expenditure on the first one, but reverse thrust. So essentially this whole lesson is going to be on thrust reverse operations and the components and locations, and just in a description of the controllers related to the thrust reverse operation. Okay, the whole idea with thrust reverse is it allows the aircraft, when on the ground, okay, this is ground only, can just slow down. Okay, and there's different speeds, and from a pilot standpoint, they're able to tell you, they'll know at what point the thrust reverse has to be in place. There's what they call idle reverse thrust, and that has to be, regulated, has to be at least at the idle reverse. But and having a full reverse thrust is rare. It'd have to be under certain circumstances because there's so much noise created from the action of this. There are levers in the cockpit where you lift them up, and that executes begins that execution of thrust reverse. So those are your two. There are two main components with the engine exhaust. That's going to be number one, your primary nozzle and your fan nozzle. Primary nozzle is for the exiting outboard of the hot exhaust gases, and the fan nozzle is actually part of the thrust reverse assembly. Okay, that's all part of that. The first one I mentioned is actually part of the rear of the aircraft. That's like rear of the engine. That's what that's for, or that's what it's associated with. Whereas with the fan nozzle, that is part of the thrust reverse assembly. That's actually on the engine fan frame and is hinged, okay, to the pylon. The brains of the operation, like I like to say in these lessons, when we're talking about the thrust reverse assembly or thrust reverse operation, it is actuated, okay, by hydraulic power and controlled. So your brains are here. Your controllers are going to be FADEC and your hydraulic control unit. All right, and I'm going to go ahead and just name some of the components that we're going to go into a little bit more, and then I just want to explain to you about maintenance on it. So for example, if there was a thrust reverse problem, what are you going to do? All right, so some of the components that we have, and just so you know, there's two halves to the thrust reverse system. There's two halves to it, so those are your thrust reverse cowls, and on each of those halves you have two blocker doors. Okay, they're interchangeably called pivoting doors. Either way, whether you say pivoting or blocker doors, they're the same thing, but there's two of them on each half. You also have switches because you have it stowed so it's flush, right, with the thrust reverser, with the thrust reverser cowl itself. But when the plane is getting ready to land and actually makes contact with the ground, okay, remember the landing gear control and interface unit, the LGCIU? that is a sensor that is then sending information to the ECU for letting it know plane's on ground, wheels have touched. Okay, and then after that, the thrust reverse system can be deployed. Before then, you have a stowing of those blocker doors. I say that because I mentioned switches. You have stow and deploy switches as part of your components. Of course, you have latches, and you want to be very careful with if you're doing maintenance and you latch them. Do make sure that every single one of them are latched securely. Even though everything locks in place and you've latched them, some of them, do double check to make sure all of them are latched, because under tremendous pressure, or namely up at 40,000 feet, that's going to eventually, that can become a problem, and we don't want to have a safety issue up at 40,000 feet or on the ground. Okay, but certainly make sure those latches are all secured. Your hydraulic unit, okay, this is your hydraulic control unit, is a very key component. You also have obviously hydraulic piping and your junction boxes. When I say junction box, I'm talking about your electrical, okay, electrical wiring. And you also have an inner and an outer cowl. Okay, and we have a photos, kind of a photos library that enables you to go in and actually see. Some of these photos are kind of a diagram of the structure and how the components are related to one another, as far as physically. The pivoting doors, like I said, are on the thrust reverse cowls, 2 on each side because you have 2 halves. Your electrical junction box is also part of that and is there. You have an inner and an outer, so that inner outer, I'm talking about concentric, like a ring. That's your inner cowl, and then of course you have your outer one that's surrounding the inner one. Your actuators are also part of all of that, and of course, like I said, the piping, and then also your stow switches, your stow switch, also your deploy switch. All right. So that gives you an idea with the components and the function of the engine exhaust system. That mostly what we're talking about here is thrust reverse, because we want to slow down the plane a lot. After it's coming in for a land, it's come down. We want to slow that down quite a bit. This enables us, enables the pilot to do this. The hydraulic energy is coming from the hydraulic systems from the green and yellow hydraulic systems for engines 1 and 2 respectively. So that's the helicopter's view as far as the thrust reverse system. One aspect I do want to mention before I talk about deactivation and lockout, because that has to do with maintenance if you're going to get ready to do that. But one thing I want to mention as an aspect is fire protection. There are thermal blankets that actually surround are part of the thrust reverse system to kind of segregate it from the rest of the aircraft, because it's a way to contain and protect the reverse thrust. Now let's go ahead and go into deactivation. Now that I've identified for you the components, or some of the components, I just wanted to cover about, okay, you're getting ready, you've got a fault message, there's something wrong, there's a problem with the thrust reverse system. Now what do we do? Okay, and this is where it's not fixable. Let's say you have a plane that's come down, and there's maybe a little, maybe some indication, but you find out this is a fault that cannot be, allowed for the plane to go back up in the sky. So here we open up the fan cowl doors. We're now going to have to deactivate that thrust reverser system. So what you want to do is you're going to have to, there's a deactivation lever on the hydraulic control unit. So what you'll do is you'll press that lever. There's also a locking pin that keeps that lever in place to lock it. So you want to make sure you do that. Of course, the first thing you want to do in the cockpit, of course, is follow the aircraft maintenance manual for absolute sequence of procedures. But you do want to make sure that no one's going to be operating or going to be or have access to the levers in the cockpit for for movement, because obviously you're trying to deactivate the system, and you want to make sure that there's no accident that occurs where somebody gets injured because of deployment accidentally. All right, so do make sure that you do a lockout, do the tag lockout. Deactivating it, you've got to put remember I mentioned the deactivation lever on the hydraulic control unit. What you're going to do is actually put that in what they call inhibit. Actually, it's labeled inhibit position. When you do that, then you're going to take that safety pin I told you about a bit ago, take that pin, and you're going to put that and install it to hold that lever in that position you just put it in. And that secures the thrust reverse system. Okay. All right, and that's on the hydraulic control unit. There's also these the lockout bolts, which are going to be used also for deactivation and lockout. They are located actually on one of the doors. Those can be, they have a little bracket where you can remove them from that bracket. All right, and again, this is locking out the pivoting doors. And there's places where you would put those bolts to lock that out. Okay, and as far as the location of those are on the lower forward face of the right thruster reverse half. Okay, so it's on the right half, not the left half, but on the right half. Okay, all right. And also, while I'm thinking about these things, there are 3 hinges. When I mentioned about components, I'll get a little bit more into that, but just remember that number 3. Okay, all right. So I just wanted to mention that to you from a maintenance standpoint, is for your deactivation, if you're getting ready to do some maintenance on it, or it needs to be locked out because it's not going to be able to be repaired for the next flight, then that's the procedure you're going to use. Okay. All right, also some operational tests that can be done with the FADEC for testing the thrust reverse system. And this is on the ground, non-monitoring, by the way, engine non-monitoring, is you want to make sure that you don't have these particular ones, and I'm talking about messages, in view. You don't want to have the STOW J5 or 6 or the J5 or 6 for deploy. So either in stow or deploy switch, you don't want to have the J5 or 6 show. Okay. Also, again, remember said about the warning notices that you put on in the cockpit when you're doing the deactivation and lockout. But once you're ready to do an operational test, obviously you need to remove those tags. So you'll do that. Okay. All right. I just wanted to give you just a familiarity and awareness about deactivation and lockout, the four lockout bolts, as well as the inhibit position, that you would put the lever in that's located on the hydraulic control unit. All right. And on the operational test, there's different. What you want to do is find, you're going to see different things on here, but you want to make sure, of course, follow the aircraft maintenance manual. You do want to make sure that the circuit breakers are closed, but you need to read to see which circuit breakers need to be closed. So do pay attention to what it says in the AMM, aircraft maintenance manual, about that. And of course, when you do an operational test of the thrust reverse system that is actuated, because there's actuators also as components of the system, you want to make sure you have hydraulic power going to those actuators to move the blocker doors. So do make sure that you have the pressurization of the green and the yellow hydraulic systems. Okay, that's, remember, engine 1 and engine 2's hydraulic systems. And then just check to make sure on the HIDE page that you do have that pressure and the right pressure, because across the board, unless we're talking about the A350 or right now I'm just on, we're just talking about Airbuses, Boeing is pretty much the same as far as our pressures, that we need to have there as operating pressure is your 3,000 psi. There are slight differences that we see on display in the cockpit, and I can tell you Rick can attest to that, and we can talk a little bit more about that later. But the operating pressure needs to be 3,000 psi. Okay, and this is just for the A320. So when you start taking gen fams for the other aircraft, and talk about the higher, heavier aircraft, we get into A350 or talking about A380, those numbers, those pressures are going to change. Why? Because now you have a higher demand, okay, because you have more stuff, if you will, more mass, with the aircraft. Okay. All right, so what you want to do, you got your engine FADEC ground power switches, your hydraulic leak measurement valves, because you want to make, when you're doing operational tests, you want to make sure you have hydraulic power there, and not have any leaks that are going to affect, of course, the thrust reverse system, because that's where it's getting its power from, its energy. So, there's that, and then your flight control sec 1, because those are your elevator computers. Your switches are also there. You want to make sure those are in their correct positions, and of course install warning notices on levers and whatnot, just anything that will keep people away from manipulating while you're doing an operational test. All right, and what you're going to do is look for the system report on the MCDU. MCDU is your maintenance panel, or your maintenance page. Here you're going to look for system report test eng for your engine, and then you're going to push the line key that's next to the FADEC indication, because you're trying to get the main menu for the engines. Okay, and then there's a choice or sub menu after that for your thrust reverse test. Okay, so then you'll select your thrust reverse, which by the way is T/R, so you'll see that on the display, on the indication. And then just, you're going to start the test, let it run. Just confirm the start of the test. So you'll do that. Okay. And then shut-off valves are important, because if we have a late, or there's some problem with the system, it's going to do some shut-off, or operate the shut-off valve. So I want to make sure it tests for that to be operationally sound. Okay, so then after it's done, because it's going to be running, it's going to automatically show up a message that's going to say set throttle lever of test engine to max reverse. You may see that on a test. So if you're asked, if we do an operational test of the thrust reverse system, and you select start test, you confirm the start of the test and let it do its thing, and then at the end, it's going to say set throttle lever of test engine to max reverse. Okay, so that's what you're going to do, is put the throttle control lever in the max reverse position. Okay, what are you looking for after you do that? You're going to be just looking on the ECAM that obviously that you're in the reverse. So REV will be the indication on there, and just after it's complete, it's going to automatically say set throttle lever to forward idle. Okay, remember I said about idle, there's your idle and then you have full throttle, or your full thrust reverse, just full throttle. All right, and again you'll see that on display on photos. We can show you what that looks like or you can, if you have questions about that, but you can see, what it will be on there. And again, if you at the end of this lesson, we will have Rick, our commercial airline pilot, who's been a commercial airline pilot for 30 some years for major airlines. He's been working for that long, and specifically Airbus. So if anyone knows about the Airbuses in and out, this pilot certainly does. All right, so that gives you an idea on the test. Obviously, when you're in front of it, it makes it's much better, and getting your hands on it. All right, okay, so got the helicopter's view as far as function, right? Your components, location of the thrust reverse system, and going into the operation, the deactivation. So if you're going to do maintenance on it, there's a deactivation of that thrust reverse system, and then locking it out until you're ready to do an operational test, in which case you're doing, following the menu. All right, so let's go ahead and get a better feel for some of the aspects to the pivoting doors, and kind of the management of the operation of it. Okay, so operation, we're talking about stowing and deploying. It's stowed away, obviously, when the plane's in flight, at takeoff, in flight, during flight, and then upon approach. But when that plane hits the ground, we have a deployment. Okay. All right, so let's kind of look at this a little bit on the management of power. Now, what it's for, the engine exhaust section. And specifically, we're talking about the thrust reverse system and its, ability to brake the aircraft, to cause some braking of the aircraft and to slow it down. The management of this energy to brake that airplane is controlled by the FADEC. Remember, I mentioned that before. FADEC is your full authority digital engine control. And part of that, you have your EIU, which is engine interface unit, as well as your ECU, which is your electronic control unit. Your actuation, obviously, is going to come, remember I said your hydraulic power, okay, that actuates the actuators that obviously are attached to the pivoting doors or blocker doors, and that allows it to be deployed. And you got the deploy switches there, so all that chain of communication electronically, electrically, mechanically is being done. Green system, yellow system. Green system's coming is for your engine 1, yellow hydraulic system for engine 2. And that's where it's drawing that power. Your shutoff valve, that's located upstream of the hydraulic control unit. And that shutoff valve, what is it doing? It's basically creating a locking system for the thrust reverse system. And the HCU, the hydraulic control unit, is doing what? It's giving command, okay, for the pressure to be sent, for the pressure for unlocking the doors, for deploying it, showing and locking those actuators. Obviously, they're tied to the doors, so essentially the doors. There's also the latches as well. So it's hydraulic control units controlling all of that. There's also a pressurizing valve, a pressure switch, again, a directional valve that's there as well. Okay. All right. And as far as the sensitivity, there's different degrees on the throttle lever. Remember I said that you have the thrust reverse levers on the throttle levers, which you do. There's that throttle level angle. Okay, and there's certain degrees where once it reaches a certain number of degrees, then you have the deployment or the execution, okay, of the thrust reverse. Okay. All right. And then also just keep in mind, your centralized fault display system, your CFDS, is interfacing with the EIU, your engine interface unit. And that's going to be providing fault diagnostics for the thrust reverse system. So just so you know, what's happening, it's monitoring, it's checking, and if there's a fault that's happening, that's when, that becomes known, and then what? If it's not repairable quickly, then that's when you'd have to actually deactivate and lock out that thrust reverse system. Okay. All right, and the more part of management, remember I mentioned the landing gear, your LGCIU, which is the landing gear control and interface unit. It has to, the HCU, your FADEC has to get the information that plane truly is on the ground, because that's the only time that thrust reverse can be deployed, and it has to get that information from there. Also, there's information coming from your SECs. Okay, that's your spoiler elevator computers. Okay, there's SEC 1 and SEC 2. Okay, and those are there where you have reverse thrust. When you have those, then the position of the throttle is going to be, that information is going to be sent to those SEC computers. Okay. All right, and let's just go a little more into the actual doors, and and then I'll get into the hydraulic control unit a little bit more, but I just wanted to get more of a description for you on the pivoting doors. They have hinges on them, obviously, all doors do. But remember, you have 2 pivoting doors on each thrust reverser half. So, those are installed on pins. The pins are going to, basically are the pins that are there allowing the doors to pivot when you have hydraulic pressure moving through. They have the actuate, because you have actuators that are moving them. So those are operated by the hydraulic actuators. All right, and of course there's 1 actuator per door, and those are moving independently into deployed or bestowed position. The pivoting door, when they're in stowed position, they're actually locked in the forward frame with a lock that keeps it in stowed position. All right. Okay. So that's a little bit on the doors. I want to go into the latches as well. Okay, let's just go ahead and look at this here. Let's talk about the blocker door latches. So we'll go into this a little bit, and then I'm going to cover some questions that you probably are going to see on a test. So if you could get out your handout, please do now, and just follow along, because it's going to be very important. I can't stress enough the importance of having you follow along and get the right answers to these questions. All right, the blocker doors, remember, they're the same as the pivoting doors. There are 4 latches. You got 1 per door. So 4 latches per door. And there's 2 doors per half. There's 2 halves to the thrust reverse system. Okay. The latches obviously are holding the doors in the stowed position. Okay, so 4 latches per door. The latches are connected in series. They're hydraulically supplied by the hydraulic control unit. All right. So, and you can see there, you got, the springs and locks and actuator there all together. All right, let's jump to a few practice questions. All right, here's one question. This is question number 1 on your handout. What is the thrust reverser assembly used for? Okay, is it for braking the aircraft while on the ground, or for braking the aircraft with both while on the ground and in flight? Okay, it's the first answer, right? I said on the ground. Number 2, what essentially makes up the exhaust system? Is it nozzle and the fan air assembly, or the primary and fan nozzles? It's B. Number 3, on each half of the thrust reversers, there are 3 hinge clevises. Is that true or false? Do you remember I said don't forget the number 3? I mentioned that earlier. Okay, there's 3 hinge clevises on each half. All right, how many tension hook latches are there in order to keep the cowls closed? Okay, this is where the doors are. It's 4. Okay, and as far as seals, fire seals, let's go ahead and talk about the fire seals a little bit so we don't, I can make sure that you understand that. So I'm going to just jump to that a little bit. All right, fire seals, you have those because remember what I said before, it's very important they've decided, okay, we want to segregate this thrust reverse system in case there's some kind of fire or threat of fire or whatever from any other part. And they've done so. But here we've got a certain structure that has the fire seals and thermal blankets. So the structure that you see with thrust reverse cowls, it has those special seals to protect against fire. Okay, and basically again it's keeping any engine fire that might be there in the turbine case away from any of the thrust reverse components, including your engine strut, fan, because remember thrust reverse assembly, all that is attached on the engine fan frame, so it needs to protect all that area. All right, so back to our practice question, because I wanted to explain a little bit on that, just so you know that it's there. All right, so on number so now in number 5, where are the fire seals located? Okay, I didn't mention that. We're going to get it right now. Okay, along edges of the thrust reverse cowls or along the edges of the fan inlet cowl. Okay, it's actually on the thrust reverser cowls. Those are where the fire seals are, which makes sense, right? You want to have it. That's where the thrust reverser is. We want to make sure, we protect that and have it right there. Reverse thrust is controlled by the ECU, your electronic control unit. But what does it use as a secondary protection against accidental deployment? Boy, that would be terrible if we had the accidental deployment of the reverse thrust. I mean, what would happen? I'll let Rick answer that question. Okay, but think about this from a physics standpoint. If you have something happen when it shouldn't be, given conditions, disaster in multiple ways. Okay, so therefore, if you don't want to have that happen, so there's a protective measure, and the answer, now you see on your sheet, there's 2 possibilities, 2 options. It's going to be your EIU, your engine interface unit, is actually a secondary protection against accidental deployment of the reverse thrust. All right, in order to command thrust reverse operation, I'm on number 7. In order to command it, the ECU needs the signal of aircraft on ground. Is that true or false? Well, I just said it was true. It has to be getting that information from the landing gear and control and interface unit in order to say, okay, yeah, aircraft is definitely on the ground. All right. In order to make sure that the thrust reverse system is working, remember I said about an operational test, at what computer can you run the test? Is it the ECAM or the MICDO? Okay, MICDO. MICDO is your main system for running things. All right. What component is fitted with a thrust reverser deactivation lever? Which one is it? A or B? It's the first one. Remember I said that hydraulic control unit. I said on the hydraulic control unit there's a lever. And what you want to do is put it into the inhibit position. But you don't want to just do that. The second step is getting that pin and installing it on that lever so that you can secure and keep that in that lock position. All right. Question number 10. For your safety, what should you ensure before working on the thrust reverser system? Okay, is it A or B? Okay, it's actually B. Okay, deactivate the thrust reverser system by using the ECU. Okay, you're going to be using the ECU to do that. All right. And I mentioned about lockout bolts. For your safety, how many lockout bolts should be used? And remember, you notice I said should be used. I could have said how many lockout bolts are there? It's not a trick question, believe me. My intention is not to trick you, but to educate you, to give you an awareness and some knowledge, information. Okay, the answer is A. Remember, I said there's 4 bolts on there, and if there's 4 bolts on there, you could use 2, could use 3, could use 1. You use 4. Okay, for your safety. All right, question number 12. The thrust reverse systems for each engine are dependent on one another. Is that true or false? Okay, it's false. I mean, the whole idea of having another system, we don't want to have one dependent on the other, because if you have a malfunction on one, you're going to have a malfunction on the other. So that question number 12 is false. Okay. All right, I mentioned about the shutoff valve. We want to make sure that we have an operational test done on that to make sure that that's functioning. And why? Why is it so important? Okay, and the answer is the second answer. It's there to stop the flow of hydraulic fluid to the hydraulic control unit. If there's some problem for whatever reason, we want to shut off, cut it at its source, right? We don't want to have the flow of that and have an actuation when we didn't intend to have an actuation of blocker doors. And where is the thrust reverser shutoff valve located? Okay, that's question number 14. That answer is under the pylon. That's where that's located, under the pylon. All right, so I've given you some good ideas on all of this. Let's go back to our lesson, and then we'll look at maybe a locking system. All right, on blocker door latches, there are 4. Remember, I mentioned that before. 4 pivoting door latches that are installed there on the forward frame, and they're secured by the 4 bolts. So not 3 bolts, but 4. You want to make sure all 4 are there securely. The latches are in series. All right, and then the latches, there's a hook that's there in the unlocked position, and that's maintained by 2 springs. You also have your actuator and your valve. So your hydraulic actuator and valve is there, and of course you have a lever. That lever is just enabling, under the action of 2 springs, to maintain the hook in its locked position. So that's going in conjunction with the hook. All right. Now, this is not a test question. It could be maybe down the line, but it's not so much it's important to know some of the critical pressures. For example, we talk about oil. It's important to, or temperature. We know it's important for you to know, at least have an idea of min max, right? You want to know what your critical point is, as far as, if you go below 22 psi, you've got to got a serious problem. You guys got something that has to be looked at. And here you need a certain minimum hydraulic pressure to release the latches. So just to have an awareness, there's a range, but just somewhere around could be between 7 and 900 psi. So just kind of an idea in your head about that. All right. Okay, and some more on the latches. This is for deploying. You've got the latch actuator that actuates the lever, and that allows. You have also those piston ports that are the port. Basically, the pistons allow that hydraulic fluid to go through the hole, which allows the latch actuator to actuate, and you have now pressure to the latch. And the same thing with the stowing, as far as the mechanism. All right. Your hydraulic actuators, just a little bit of detail on this. I mentioned that there were 4. They are mounted on the forward frame, so you'll find them there. Rod-end assembly. Those are how they're attached to the pivoting door structure, and they're for deploy and stow. Okay, I mean, it's, you know, pretty straightforward that way. Okay. All right, let's go to a few test questions. All right, let's do number 15. This has to do with a locking system. The thrust reverser locking system, this is not on all A320 aircraft. So if you don't see it there or see indication of it, it's not because maybe you didn't know. It's just that particular Airbus does not come with it, does not have it. So the answer to that is true-false question. It is found on all A320. That's not true. It's not. Number 16, one of the functions of the HCU is to control and regulate the speed of the blocker doors. Okay, right. We're not only just talking about position when we talk about actuators and giving instruction, but we're talking also as speed. So position and speed. Here we're talking about one of the HCU's functions is to regulate the speed of the blocker doors, and so that's true. The answer is true. Where's the hydraulic unit located? Okay, seems like things are on the right. So right hand, it's the right hand thrust reverser forward face. That's where the HCU is located. All right, for your safety during maintenance, which valve, this is question number 18, by the way. For your safety during maintenance, which valve related to the HCU can you use manually to close and pin down in order to avoid accidental deployment of the thrust reversers? That's your pressurizing valve. Okay, so the answer is the first answer. All right, question number 19. Which hydraulic supply, green or yellow, is for engine number 1? Just thought I'd throw a sort of a freebie in there. Okay, green. The answer is the second one. Green hydraulic systems for engine supplies engine 1. All right, number 20. What must you ensure first before doing a thrust reverser operation test? Okay, is it the directional valve is open or the AMM, your aircraft maintenance manual, specific circuit breakers are closed? Okay, I mentioned about circuit breakers. It's important you close them. That would be number 20. Otherwise, you're not going to have an operation. You got to close the circuit. Okay, last question. Question number 21. What is displayed on the MICDU after the thrust reverser operation test is complete? Is it the first or the second answer? Okay, is it to start restow test or set throttle lever or test engine to max reverse? All right, the answer is the second answer. I mentioned that before. You're going to see that. All right. Now you got to handle some of the questions here for this this whole thing on thrust reverse. All right, so we talked about the hydraulic actuators on the block, for the blocker doors. We don't need to go into great detail about that, return pressures and all that. Supplying and then your return pressure to operate the actuators. Just know that they're there. There is a minimum hydraulic pressure to operate the latches so that you have a deployment. Okay, you had your your stow and your deploy switches. Okay. All right. Manually, if you were to do a manual operation of the blocker doors, okay, from the hydraulics control unit, you want to, of course, follow the aircraft maintenance manual, but do make sure. This is from your panel 115VU. 115VU, I've mentioned that before in other things, is your main engine. That's your engine panel. Okay, and then of course you have your engine FADEC ground power switches, and they have to be in the correct positions. Of course, again, like I said, you want to make sure if you're going to be manually operating anything or even automatic operation, once you start turning things on, you do want to tag off the things that can move, and make sure nobody tampers with any of that. Okay. All right, so that gives you a pretty good idea of the components of the engine exhaust system, the function of the engine exhaust system. You know, there's not much to talking about primary nozzle. That's part of the rear part of the engine, and that all has to do with just exiting outboard the hot exhaust gases. The primary objective of this entire lesson is to understand more about the thrust reverser system, which we just talked about, or got into detail about. That fan discharge air to the fan nozzle is all part of the reverse thrust assembly, which has the pivoting doors, which have the actuators along with that, and your latches and all that. So, and then of course your controllers. Your controllers are your hydraulic control unit as well as your FADEC. Okay. All right. There may be some nuances that we can talk about in other presentations, audio and or visual, video presentation, on the slight differences that you may come across in the field with your Airbus A320 variants. Okay, so, or even just from one model to another, because it's the A320 family, but you have those slight differences between A319 and, say, the A321. Because A321 can be kind of a little tiny separate beast from your 19 and 20. So those are the little things you would need to be aware of. Okay, just remember which aircraft you're on. I'll definitely follow, your maintenance procedures to the letter, please. And of course, if you have any questions, definitely ask. I'm talking about when you're out in the field. If you're not sure about something, please, definitely ask. It's worth doing so for safety reasons, for yourself and for the plane. All right, I hope you learned something from this, and good luck on the test. If you followed along with me on the handout, then you're going to do pretty well. But certainly if you have anything that doesn't make sense to you, just email us and we'll do our best to answer those questions. All right, look forward to having you in our other lessons.